Hi, this is Tom, and today, welcome to lesson 33. This is lesson 33, correlation. And here's what correlation is. Let me give you a definition. Correlation is a measure of how linearly, we'll explain that, linearly related a set of data. So, a data, not a date, data. And linear, or linearly, is a line. Now, I have these two scatter plots from our last lesson, and let's take a nice marker. How about we use red today? And notice this. If I take my red pen and I sketch a line between those dots, they fit pretty close to that red line. Now let's try that. And let's take a note on that for the red line. So notice that as principal, or as time increases, principal, or I should write it the other way, actually that might be better, as principal increases, time decreases. We call this, or in other words, as one number gets larger, the other number gets smaller. For example, here where principal is 20, time is up over 5. But when principal is here at 60, well then my time back here is just over 3. So as one gets larger, the other gets smaller. We call this, and so when one value increases while the other decreases, the data is inversely proportional. Inversely proportional. Okay, now let's do another line. How about this one we'll do in this bright blue color. Now notice here, it's a little harder to fit a line. See, I can maybe like that, but let's try this one instead. Well, that looks a little bit better, and maybe I'm being a little bit silly here, but maybe if I was to have a bigger blue line, well then it fits really well. So maybe that was a little bit big on the blue. How about something more like that? So if I had a bigger blue pen, yeah, that looks much better. And so this one, we say the blue, let's see, oops, we'll make a smaller one again. Since each value increases with each other increases as the other increases, then the data is directly proportional. Okay, now let's take a look at this. Correlation is a way of determining how well a line fits the pattern. And you can see here in the loan payments that the line fits really close to all those dots. And if you look over here, let's undo this big blue line and let's put a smaller blue line back. But if you notice here in the blue, we have some bigger gaps of the data away from the line. And so it fits, but not quite as well. So what we do is correlation measures that fit. How tight is it? And not only that, it tells us if the data is inversely proportional or if it's directly proportional. So the measured correlation, and let's do this. Correlation is represented by R. And if data is directly proportional, R is positive, and R is negative, for inversely proportional data. So when we look at our loan up here, we're going to have R is positive. Oops, I'm sorry. In this case, I'm sorry. Since it's decreasing, R is negative. And for our height and shoe size, we would say that R is positive. Now, not only that, but if it's perfectly correlated, so if data is perfectly positively, or yeah, perfectly proportionally related, proportionally related, R is 1. And likewise, if data is perfectly inversely related, R is negative 1. And that's actually the largest and smallest that R can be. And so what we say in general is that we say that R is somewhere from negative 1 up to 1. And when R is close to 0, then we would say no relationship exists. No relation between the data exists. All right, so that's the idea of correlation, and R is just a way of measuring what we can see. And for example, here on the loan, I would guess that R is close to -1. And on the height and shoe size, R is fairly close. It's probably not as close as the loan, but is fairly close to +1. Well, in our next video, we're actually going to find out how you calculate R, and we're going to start by doing that with our example of the loan data. See you in the next video. Thanks for watching.